So like I said, I'm going to make this really be a 1. February's really a 2, and so on. This works really similarly to the table question we were doing yesterday on one of the lesson masters, where you had questions that looked like this, like where it said evaluate f of whatever, g of whatever. Okay. So where it says evaluate f of 6, what is that asking you for? Drew?
What's the temperature for the number 6?
Yeah. So I want you to look and find the 6, so that's June, and I want you to read that value, and I want to know what is the value of it, meaning what is the y value. What do you want to call that? 75. I feel like that's pretty safe, okay? So average temperature here, 75 degrees. So what is this next one asking you to do? F of 4 minus f of 2. That?
Find the temperature for spots at 4 and 2 and subtract them.
Good. So f of 4, what do you want to call that? Maybe 53? You agree? So I'm going to go 53 minus f of 2, which is here, 36. You agree? Okay. 53 minus 36. Let's see. I think that's going to be 17. Someone check that for me. Is that right? Okay. What does that 17 mean? It's the difference. It's how much it increased from February to March. Or sorry, from February to April, because that was months 2 and 4. So the temperature increased. $17 from March. No, just kidding. From February. Why I'm so fixated on March to April. Okay, so from February to April, we saw a net increase of 17 degrees. Drew?
Will we ever get things like this where it could either be like 56 or 57 or something like that on the quiz? Like when you're looking at the temperature and the graph's not accurate.
Oh, like as far as estimation goes, as long as you're close, that's fine. Is that what you mean? Like if you called that, 54 instead of 53, or if you had called this 35, that would have been okay. So your answer for this might be a little off, but if I can see this, I can see like, oh, well, they were one number off here and one number off here, and again, your estimation is no better than my estimation, no better or worse, I should say. Okay, they're all just estimations. So, okay, so now this next one says evaluate f of 12. All right, so f of 12, that's in December. And that's actually this line here, so that's kind of misleading. Should we just go ahead and call that 50, or you want to call it 49? What do you want to do?
49.
All right, 49. Way to be accurate. Okay, so 49 minus f of 8, which is over here. What do we say there? 86 maybe? And then on the bottom, it just wants me to subtract 12 minus 8, which is 4. We did one kind of like this yesterday. All right, I'm going to cheat. 49 minus 86, negative 37. And then I'm going to go negative 37 divided by 4 is negative 9.25. Now, what does that one mean when I divide like that? Let me help you out a little. Up here when we did the subtraction, that told us the difference, right? That told us how much it changed. Why would I take that change and divide? Clarence?
Show the average amount of change between each month, between those 2 months.
Perfect. So it's the average change per month. So How do I want to word this? From August to December, what happened to the temperature? It decreased. An average, because it's not exact, right? It may have gone down more in one month than the other, of 9.25 degrees. And really, in something like that, I would probably just say about 9 degrees per month. The important parts of your answer there, the parts that, like, if this were a test question, I would want to make sure that you had correct, is I want to see that you know it's an average change. Okay, it's not the exact change. And I would also want to know that it's per, well, this one's per month. If it was in years, you'd be saying per year, or per hour. That it's a change for each individual time slot, not just the overall change. Okay? How you feeling on that? Okay? Connie? That's a great question. When a division problem is written with this fraction bar, grouping is implied. So it's implied that this top part should be done together and this bottom part should be done together, and then that division is the last thing you do. Okay? So you're right. If I had written this out as 49 divided by 86 and then just the regular division symbol, then I'd want to do division first. But when division's written this way, it's top and bottom first and then divide at the end. Does that make sense? Okay. Good question, though. All right. And then domain and range. My graph's kind of going away, but you've got it in front of you. What is the domain of this function? Ryan? The months. Yeah. The domain is the months of the year. Sorry, that's me. Which numerically would be like 1 through 12, right? Would be your domain. I guess I should write that a little more technically, but what would you say about the range? Okay, it's the temperature. If I wanted to talk numerically, so let me write down that the range is the temperature. And I think you could argue this two ways, okay? You could say, well, on this graph, it's between 30 and 90. So you could get away with saying the range is from 30 to 90, okay? But if you always, for temperature, is that always your range? Can you go below 30? Yes, unfortunately. Can you go above 90? Sometimes, okay. So you could get away with even saying, like, hey, it could be all real numbers here, okay? Because it could be any temperature value. I guess in a real extreme sense, we're not going to probably get into, like, negative 70 or anything like that, but we don't know. Drew?
Using the information given, though, doesn't it have to be what you plug into the domain that would give you the range?
Yeah, and when we talk graphs, that's a really good point. For this, and this question does say for this function, when we talk domain on graphs, and we're going to talk about this in just a minute, we do say where's the lowest point on this graph and where's the highest point on this graph. So I'd be fine with you even saying from 30 to 90 because that's what's shown, or identifying this as being, this is about 35 and this is about 85, so somewhere between there. Does that make sense? I think you could argue either one. This one just because we could continue this graph over time. That's sort of what point, like, this graph really has arrows on it, right? Because we keep measuring temperature. But, so that's why I'm saying that there were other numbers that are possible, but based on what we're given here, it would just be these values. Okay? So kind of a confusing one. I would take, like I said, I think I would take either one. Okay, that's reading stuff off a graph. Are you okay with that? Anything there that's tricky? Okay, this next part's going to be even easier because I think you've seen this before. I hope you've seen this before. Do you remember what makes something a function?
Yeah.
Drew, go ahead.
For each value in the first set, there's only one value in the second set.
Yep. And when we're talking graphs, what are our sets? X and Y, yep. So if you're looking at a graph, okay, let's look at our examples first and then we'll go back and write what the vertical line test is. If you're looking at a graph, a curve on a graph is made up of a bunch of points, right? So if I pick out this point on the graph, that point is saying, hey, this X value pairs with this Y value. Okay, that point is representing a pairing between an X and a Y, right? This point is saying this X value pairs with this Y value. So you want to make sure that for every X point, for every X place that I find, there's only one place on the graph that would match up with it. Okay? Look over here what happens. Let's say I let X be -2. Do you see that there are two places where X is equal to -2 that have two different Y values? So this is not a function because this X number matches up with this Y value and this Y value. That makes sense? So we use something called the vertical line test. If anywhere on your graph you can draw a vertical line and it only crosses your graph one time, then your graph is a function. Okay? And really that's because you're testing this. You're looking out for this kind of thing. But if anywhere on your graph you can draw a line and hit more than one point, then it's not a function. Okay? So let's kind of write that in words. If a vertical line, I'm going to abbreviate this a little bit, is drawn anywhere on a graph, and it only intersects the graph once, the graph is a function. Is a function. Okay? If it crosses more than once, then it's not a function. Have you seen this before? Yeah? Okay. So probably you don't even need to be real detailed there. You've used this before. But I just wanted you to understand why that vertical line test works the way it does. Is because what that's really telling you is that that X value right there matches up twice. Okay, so like I said, I think the hardest part about this is this. Domain and range from a graph. Okay? Which you guys have already sort of started to pick up on, but. Okay. What's domain again?
First set.
Okay, it's the first set. So on a graph it would be the, okay, so it's all the possible x's. Which means the range is all the possible y's. Good. Okay, so let's look at, first of all, look at this one, and then look at these three, and tell me what's different about this one other than it has the grid thing on it. What's different, Shy? Okay, I have to do the numbers because it's got specific endpoints, right? Here, I don't have the numbers, and what do you see at the ends of the graphs? Arrows, because that keeps going. So I don't really care about the numbers because it keeps going beyond what's even on my graph, okay? So we're going to kind of approach these in two different ways. If it's finite, which you may want to write this down, this is what's called a finite graph. Have you heard that word before? It's opposite of infinite. Okay? Finite means it ends. Okay, there's a beginning and there's an end. It doesn't go on forever. Okay? Just like you're hoping this class will be finite. If I want to list the domain here, I can say specific numbers, which is why this graph gives me specific numbers, because I can see a beginning point and an end point. Put your pencil on the point that's the farthest to the left on this graph. And then check with your partner and make sure you're choosing the same point. What point on this graph is the farthest to the left? Did you pick this? Yeah? Anyone struggling with that? What's the x value right there? -4. Now let's look at what's the point that's the farthest to the right. That'd be the 3, right? Okay. So here's how we're going to write our domain. We're going to write it in interval notation, which I think we talked about in one of our lessons, but just write this down and then we'll talk about it. We're going to start with our smaller number, -4. Then we're going to say less than or equal to x, less than or equal to 3. That is the mathematical way to say all of your x's are between -4 and 3. Okay? All of your x's are between -4 and 3. This piece of it, by the way, is going to look exactly the same every single time. Start with your smallest number, do less than or equal to x, less than or equal to, and then your bigger number. Okay? Okay, so that's x's. Let's look at y's. So what am I looking for when I look for range? Let me change how I ask that question. Domain, I was looking left to right. How far does this graph cover? For range, what am I going to look for? Up and down. Good. Where's the lowest point on the graph? Put your pencil on it and check with your partner. Lowest point on the graph. Any controversy? Anyone pick something different than someone else? Did you pick this? Okay. What I get with these a lot is people really want to fixate on the end points. And so I have a lot of people say, oh, well, this is the lowest point and this is the highest point. It might be that your end points are the highest, but you see this graph actually dips below its end point. You want to find the lowest point overall, the lowest anywhere on the graph. So that'd be this, which is at -2. And then where's your highest point located? That's up here at 4. Good. So you're kind of like boxing that graph in. Okay, I could like fill these lines in, it would draw a box perfectly around the graph. So this time I'm saying my range, again, start with your smaller number. Anyone know one thing I'm going to change this time? Clarence?
Put y in the middle instead of x.
Good, put y in the middle. -2 less than or equal to y less than or equal to 4. So that's what your domain and range look like when it's a finite graph, when you've got endpoints. Okay? You feel good about that? If I gave you a whole page of just those to do you feel like you could do it? Boring, but you could do it, right? Okay. You guys are kind of zombie-like today, so if I'm freaking you out, let me know. Okay? Let's look at this graph. Let's look at this infinite one. This one, it's not possible to pick a point that's the furthest to the left or the furthest to the right because the arrows tell me that it keeps going. So what I want to know is, does it keep going forever? And I will tell you, and a lot of you for this one can look at it and say, yeah, for sure. But let me show you sort of the trick that I use. The behavior that you see on the ends of a graph, that behavior you can always assume keeps going. Okay, so don't assume that your graph is going to like come down and then like start swirling around or something crazy like that. Okay, if it's got an arrow pointing this way, that means it's going to keep going this way. But also remember that there's no such thing as a graph that curves and then turns and goes vertical. Okay, if it's curving, it's always going to be curving. So if I were to go way out here on the x-axis, would your graph eventually hit that pen? And when I do that, imagine that my pen is infinite. Imagine that my pen like is a wall that goes on forever here. It would eventually hit that, right? Would it hit over here? Would it hit everything in between? Do you see any gaps or? Okay, so what do we say for our domain? Oh, good guess. Infinitely many. There are infinitely many values. I want to say, what numbers will I hit? How do I say every single number? All reals, yeah. And I'm just going to use the symbol for that. Okay, or you could write it out in words. So my domain is all real numbers. For range, I'm going to do the same thing, but I want to think about up and down. Will my graph eventually hit everything up and down? Yep. Hits everything up, hits everything down. So what do I say for my range? All real numbers again. Good. Okay, that one. How many of you feel like you knew that one before I even did the pen thing? Good. Okay. They do get a little harder, but if you can visualize this, you're going to be way better off. That's awesome. All right, let's look at this bottom one in the corner. Domain. What do you think? True?
All real numbers. All real numbers. Yeah, all real numbers.
All real numbers. Good. I see what you were thinking about. But for domain, remember, I'm just looking at left to right. Will this graph eventually hit both of my pens? Yes, it will. Okay, so for my domain, sorry, this is a little, let's shut up a little bit. For my domain, I'm going to say all reals. Because I hit everything on the left, everything on the right. Oh, I said those backwards, but it's all right. What about up and down? Do I hit everything up? I do. Do I hit everything down here? Will I hit my purple pen? No. So when you have a no, then you have to say, okay, so how low does it go? What's your lowest point? -2. Okay, so how would I write my range? Go ahead, Drew.
All real numbers greater than or equal to -2.
Perfect. And notice he said greater than or equal to because my graph does actually hit -2. Okay. Good there? All right. The trickiest of them all. This one. Domain. Will I eventually hit both pens? Will I hit everything in between? Do you see that there's a gap here? What is that gap equal to? What number value? 0. My graph will never hit 0. So I want to say somehow in my answer for domain that my graph hits everything positive and everything negative but doesn't hit 0. Think about how you would write that. Go ahead, Drew.
All non-zero real numbers.
Ooh, you could do that. If you want to write it in words, you could write it that way, non-zero real numbers. That would be a good way to do it. Anyone know how I could do it in symbols? Because I'm lazy. Brennan? Good. All real numbers that are not equal to 0. Okay. But if you wrote that out in words, if you got mixed up on the symbols and just wrote all real numbers not equal to 0 or all non-zero real numbers, that'd be fine too. Okay. Let's look at range. Do I hit everything above? I hit everything up here. How about down here? No. What's the lowest point I hit? It's kind of a trick question. Okay. Good. Okay, and I see a couple of you saying 0. You're right that it doesn't ever go below 0. Does it actually hit 0? No, it's going to like skim right across the top of it. Okay? So it's always going to stay above 0 but never actually hit 0. How do I write that in symbols? Clarence.
Real numbers greater than 0.
Yep, but no equal to this time, right? Because I don't actually hit 0. The other thing you could do, what kind of numbers is this talking about? Positives, right? This is everything positive. So another symbol you could use is you could do the all reals with a little plus above it, and that means all positive numbers. Be careful about using this symbol. This symbol does not include 0. Here, that's okay because we didn't want to include 0. But just be careful if you're doing a problem that you do want to include 0. Remember, this symbol does not technically include 0. Okay? How you feeling on that? Yeah?